Dysfunctional vet with a breakdown of the mini lathe. Now I'm going to go through this kind of quickly to tell you what happened. First and foremost, I was threading or actually I was tapping, and my chuck stopped turning and I couldn't get it to work. The difference between reading a book and experience is, with experience you know more about what's going on than just reading a book. I'm still getting experienced with this. I've made one project on this so far, and all it was to kind of learn a little bit about one of the cutting tips I had. But let me show you what I have and you'll understand. Alright, here's the motor that runs the thing. And this motor has a belt which I have misplaced. Here we go. This belt is a 1.5 by 70. This belt comes up and it turns the gear that fits on here, which as I put it back together, I'll show you this. And I'm going to clean up some of this stuff right here and oil this. Smear some grease or something on there. Alright, this belt turns this, which turns this, which turns the chuck. A moment ago I could not get this thing to engage, and I had forgotten that there was a gear in the back, and the gear had slipped out. It was sitting right there, so the shaft turns but there's no output, and I couldn't figure out what the problem was, again due to a lack of experience with this piece of equipment. I now know if I have these kind of problems, check this gear before anything else. The Harbor Freight doesn't have a real great troubleshooting deal on there. There's 3 screws that hold it on there, which are here and here. It's the largest of the Allen wrenches, and you have to remove the motor to get to this one. You have to remove the instrument panel and a small plate, which sits right here, which is part of the shield for this shaft. Now, there are 2 wires that run up into this thing, and I haven't decided for sure what I'm going to do with them yet. These wires are the safety switch right here, and I'm not a big fan of shielding everything so darn much that you can't see anything. I realize that this thing mostly covers the chuck, but the key word here is it mostly covers the chuck. When I took a machine shop, the machines that we used were industrial grade. They had very few safeties on them. You were expected to know how to run the equipment, and I never worked with a lathe. I'm going to tell you that right now. I worked with an end mill and some other pieces of equipment, but never got to mess with the lathe. Didn't have enough hours in the semester. But as I was saying, safety equipment is all well and good where you need it, but a lot of times it's really in the way. And I realize you're trying to keep people that aren't competent from getting hurt. Some of this work that I did, I had to take my glasses off in order to be able to focus on what I was doing. Once I figured out what I was trying to do, then I put my glasses back on and worked so that I wouldn't get anything into my eye and get damaged. But let's start off with the chuck won't turn, but the motor is turning. Check your gear level and the gear high and low in the back. Make sure that you are fully, and you may have to turn this a little bit to get it to go together. I mean, it is a teeth on teeth. I think it's worth your time to go ahead and order a new set of these teeth and hope that these other teeth don't go bad, because this is a pressed bearing. I haven't dissected the front up here, and so I'm not sure exactly how that's put in. This uses a wrench that I don't have. I'll have to make one if I want to take this apart. And it would be a bear to replace those plastic gears in there. A real bear. It'd probably be cheaper to take this to a machine shop and get them to press it out and put the new bearings in than it would be for me to try to do this, because I'd have to go buy all that equipment. And sometimes it makes sense to buy something, sometimes it doesn't. As I said, I bought this because I need some parts made, and it would cost me more than this piece of equipment and all of the attachments I have to make those few parts. The price of everything has just gotten out of hand. So this piece fits onto here, the screws come up, and it tightens down. As soon as I get this all cleaned up and get this coated with some oil and grease, I will put this back together, and then I'll show you the next step of reassembling this thing. To take it apart, you would just do it in reverse. I did not photograph me taking it apart. I did think about it, but if you're like me, you get started on something, you say, well, yeah, and everybody goes, yeah, shut up, you old coot. Anyway, with that said, I will move on to the next step. All right, here's the motor right here. Now there's two screws that hold this in place. It's a direct drive belt here that comes up to this pulley up here. Sorry about the focus, there's nothing I can do about that right now. It's just too tight in here. This is our power cable and all that good stuff, and that will be pulled through the hole in just a moment. This cable will come up here, and there's a cinch on the back of it right here. Takes a Phillips screw, you slide it up, torque it down, then put it onto the motor, and life is good. Now there you can see the two bolts. Anyway, I'm getting ready to bolt this up. The bolt on the other, or the nuts on the other side, consist of a lock washer, a washer, and a nut. Now there's all kinds of little stuff falling out of this. See this? That's just a piece of plastic. But there's some other stuff falling out that I don't know what it is. Here's one piece right here. It looks like a spacer of some kind, but I have no clue where that is supposed to fit. There's been some other stuff that's been falling out of it too. The assembly process, and I'm not faulting these guys. Things happen, but to use the vernacular of NASA, they need to vacuum a little bit more when they assemble this. So I'm getting ready to put the motor back in. After I put this motor in, I'll put this drive gear on here, I'll put the belt back on, then I'll tension this so that it has the proper tension, and it is tight. This belt looks like it's in good shape, but it also has some fractures in it, which makes me think that it's partially rotted. So I'm going to go ahead and order two of these. This is such an easy thing to change. I mean, this is no big deal. You can walk it off and put it back on with very little disassembly back over here. These are the gears that you would be changing when you're cutting different threads. And I was hesitant to really dig into that until I had to. Today I had to. It's easy as pie to do that. So let me tighten up the motor. We'll put the drive belt on. I'll show you that, and then we'll continue to assemble. Alright, now this has got to be a real different look from the past. This right here is your neutral, high and low, I think. I'm not sure. I'll look it up. This has got to be a change from what you just saw. You have this right here. You pull out on it, and you can adjust so you can have a neutral, forward, and such. The gears, this plate right here has these two gears and the handle on it. This assembly piece has the little screw, has the little gear, and then of course the Allen wrench screw. That little piece that I found that I said they needed to vacuum and clean is the slot that makes these things turn. Without that, these things would just spin on the shaft. They're not moon keys. Moon key looks like a half moon. But anyway, it's a slotted key is what it is. This piece goes in the back over the motor and protects some wires that are back there. At this point, what I'm going to do is I'm about to turn it on and plug it back in because it's unplugged right now. I'm going to plug this back in and I'm going to test it to make sure it's working properly, and then if it is, I'll continue assembly. There's a plate that goes on top of this. This is the plate right here. That goes onto the top of this. It has 2 screws in the top, and there's a plate so that you can slide something longer through this. I'm going to go ahead and take that little cover off and probably stick a magnet or something to keep it there, so that if I ever need to pull it off, I can, because it's a pain if you have some long stock and you want this extra deal. This throat in here is pretty large. However, down inside here there is a choke. Can't see it from this side either, but there's a choke on it which drops the shaft that it can actually hold significantly smaller. It's a bummer that it's that way, but it is. So what I'm going to do now is I'm going to test it and see if it works. Okay, it works in both directions. I'll continue assembling. I've got this little guard that goes on first before this plate does. I have this plate that goes in the back, and then I have the back assembly here to put on, and then it will be all reassembled. This was a real good breakdown. I hope I don't ever have to do it again. Changing these gears out though, now that I've actually pulled them off, put them back together, it's nowhere near as much difficulty as what I was expecting, and for that I'm happy. With that said, I'm going to close this out, dysfunctional that out. Dysfunctional that. I am making the deer scare. The rod has been cut, but it's not smooth. I'm smoothing it out before I make the center bore to start drilling it out for the little deal to scare the deer off with. This is a soft steel, and I'll be boring it in just a moment with the high-speed drill center, and then drilling it with the drill using the tailstock here. Taking off about 2 to 3 10,000ths on each pass, because the thing is, the metal itself is actually physically bent. It's not a real smooth bar. We're taking off another 3 10,000ths. This should be my last pass right here. The tip is a tungsten carbide that's been brazed onto the high-speed steel. I'm going to have to do it one more time. Well, let's make one more pass on it. All right, this is going to be 5 10,000ths. All right, now we're ready to center bore it.